Alright guys, so as is right now, I've just got it reassembled, and the thing that was really tricky, that was giving me a hard time, is that this entire part is connected to nothing. It's completely isolated as is here. And I believe I showed you guys on the previous video. I actually, you could use a multimeter, voltmeter, but the best way to actually test these things, I don't really trust those things, is to use the spark test, right? Just a low voltage, like 6 volts is good enough. It's not going to damage it or anything. But the thing is here, there's the, let me just adjust that. There's the terminal, the contact point on the relay, right? This is the main part. Remember, the two little terminals of the relay, they're completely isolated from everything else, so we can, remove them from the equation. But here, so the bottom contact point, remember, it goes to the it goes here, then here, and it goes to the two ends, to both ends of the both ends of the coils, right? And so where does the electricity come from? Where does the circuit end? Right, so following here, you go, there's the other contact point, goes here and here, it's connected to this. This is connected to this. You see, it's not isolated there. It's just welded on there. You see, there's no this brown plate here. These brown plates, they don't let electricity through, right? So that's another thing I should mention when you're dealing with these electrical systems. If you have some sort of like rust or damaged plates, these brown plates, or sometimes you've got like grease and oil, it's gonna allow some electricity to flow through, and that's not good. You want them to be nice and clean like they are here, and they look brand new since 1947. Remember, I didn't clean this at all. I opened it up and it was like this, so it's a true testament to how good these things were built. Now, unfortunately, the manual, it doesn't, go into a lot of detail in the circuitry, and they don't even have a circuit diagram for this. They just have, the general diagram showing where these 4 terminals, where they go to, and that's pretty much it. They don't have a lot of other detail as I'd like them to have. So, although they're pretty good, they still have their shortcomings, right? And this is one of them. And so, damn, I spent a lot of time thinking about this and looking at this. And then I remembered one thing. Under the lid here, you'll see that these brown things, they're sort of like a I think it's what's it called? Silicone plate, PCV, something like that. Whatever. Once again, it doesn't let electricity through. It's an isolation, right? Insulation or isolation, whatever. And these just isolate those two terminals there. And there's them on the other side, and you'll also have to check those. Make sure they're good. They are good here, right? And then here, for the big ones, one of them is insulated. There you go. This is also an insulation plate that goes on top of there. But the other one, this is made of steel. So here's the catch, guys. It actually, this terminal, as I said, if it was just completely isolated, then it wouldn't make sense, because you'd have an incomplete circuit. Where's the electricity coming from, So it comes from here. So there is a rubber, and it looks like a piece of wood. I don't know if it's wood or not, but it's an insulation plate. I don't think it's wood. No, it's just same as this brown stuff here. But it insulates this part in the center from the housing here, from the case. So straight away, that tells me that this should be negative, right? Because if it was positive, it was supposed to be connected to the ground, there would be no need for this insulation here. Now it's different on the other side. So now the question is, which side does this go to? And you see, if I remove it, obviously these little pieces of rubber, they could have done it better. You see, what I'm going to do is I'm just going to make a big plate. Just cut a big piece of sheet rubber and just put it there. You know, this here is pathetic. Look at that. It's just thin, broken, and pathetically small. That's really, you know, once again, they still have their shortcomings, you see. But everything is still in great condition. I'm just real critic, guys. I'm just a real critic. So the other one, and you'll see that it's got a bevel on it. Let's see if I can get the bastard to zoom in. Hang on. Anyways, this bevel here, it fits in perfectly with the hole here. You see? But it also fits on the other side. So you're thinking, well, does it matter or not? Well, it makes a huge difference. And unfortunately, the manual doesn't mention this. Okay, it doesn't mention this at all. So here, on this terminal here, sorry, pardon me. This terminal here, I don't have it now. But remember, there's that steel tab that goes to the starter. So this here must be negative. But it can't, it's only negative when you turn on the starter, because remember what I did on the car? Actually, I don't know if you guys have seen it, but in order to activate the starter of the car without, let's say you don't have a key, that's what you do to start the car. You jump this terminal here. Just got a chisel or something, just touch these two like that, look. That would turn on the starter motor. Now if I just do the ones on the bottom here, it's just going to turn the starter motor. It's not going to turn the engine because it's not pushing anything forward. Remember that you got to engage the plunger here in order to get this car started. Right, so these two, this guy is just for the starter, and now it's also connected to the other terminal. Remember, to the terminal of the other coil there. There's the wire there. See it there? Right, so the best thing to do in these cases is I just drew myself a big diagram of how things are, and as you've seen, I've got this part here incomplete because although I put it as a wire here, it's not a wire really. It's just the electrical connection from the this steel part here, right? So really, this wire here, it represents this here. Now here on the terminal on the right. Over here, you can't connect the battery terminal here. That wouldn't make any sense because it would just keep the starter motor on all the time. So the battery cable has to come here. That big, thick battery cable. The negative battery cable in this case. Most cars, it's positive. But on the 1947, on the 40s, it used to be negative. So this would be the big, thick negative cable from the battery. This one has to become negative, right? So the normal position is this is off. So when it's off, you know, it's not insulated. It's actually connected to ground. So when you have something that's off, this is actually a positive terminal. because remember, it goes to the motors, to the starter motor here. The starter motor has lots of windings, and then it goes to the, it's actually connected to the ground of the car. Electricity has to go through these things in order to make the starter turn. So it's not like you're thinking, well, electricity is a short. Well, everything in electricity is a short circuit. How can I explain this? You're always going to have the negative touching the positive. That's what a closed circuit is. A short circuit is, just as the name suggests, is just a really short, direct, closed circuit. In the normal circuit, it's going through all those windings, and those windings are, using up electricity. Whereas if you just touch 2 points together, it's just going to melt the points, right? Or just get them really hot, depending how much energy you have. Well, there's my hat there. Where were we? Yes. So like I said, this part here is represented by this wire here. Now we need to know, is it connected? If I put this here, then you see this is no longer insulated. It's actually connected to the starter motor. And thus you're going to have positive, positive stuff, if you will, the positive side of the electrical circuit connected to the, also to that, side of the coil there, which I represented here. You see, this part here is this terminal here, which is actually, so not the terminal, it's actually down there, right? Now this one, on the other hand, it's always negative because it's connected to the negative side of the battery constantly. It's never off. This, on the other hand, now watch what happens. Here's the big difference. When these two are disconnected, if you were to actually put a terminal here, take a multimeter and put another one here, you'd get 6 volts across these two. If they were the same terminal, or if this was connected to nothing, then you'd get 0 volts. So therefore this is positive when it's off. Now when this is on, when the plunger is on, remember it connects these two. So once these two are connected, electricity then starts to flow from here to there, or, the other way, but it doesn't matter now. These two then become one. Therefore, this one here, it becomes negative. So what's the difference between these two? This one is always negative. This one is positive normally, and it's negative once you turn this one on. Now that makes the whole lot of a difference, because you see this part here in the middle, it now connects this terminal to this plate here. But which way does it go? Does it go here? Like, is it always negative, or is it supposed to be connected to ground first and then switch to negative? Well, since we're talking about coils, it doesn't really make sense for it to change. But anyways, let's follow what the circuit would happen if it was positive. So if this side was positive, so it would be ground. Let's just assume, and this is, I'd like just to mention, guys, quickly here, especially with me, I used to think, before I had a better understanding of electricity, I used to think that, you'd have positive and negative. There's positive stuff and negative stuff. And they'd meet at a light bulb, for example, and, shock each other and turn the light bulb on. And I'd actually think that the positive stuff was protons and the negative stuff was electrons. So I used to think that it was, let me just get something better to draw here. There we go. I used to think that you'd get positive here, go light like that, negative here, going like that. Here's the light bulb, turn it on, right? That's what I would think. So I think that, if you have a switch here, the switch is open, then you'd have no electricity here, and I'd say, well, this side is connected to the negative, it's just no electricity. So this bulb is negative, and that's sort of right, but this is completely wrong. Negative and positive is just assigns a direction of flow. Electricity, like I said, it flows like water. Right, so it's actually going back to itself. You need to have a complete circuit. That's why they call it a closed circuit. It's literally closed. Everything's got to be connected for these things to work. If you have something that's one single disconnection here, then it's not going to turn on that light bulb there. Right, but the thing is, now going back to that, let's say you have the positive terminal of the battery here, and here you have the lots of turns of wire from the starter motor. Here's that terminal here. Here's another terminal. This terminal is connected to the negative here. Right? Now, since this is connected to positive, to ground, this entire part here, it's actually connected to ground here. Similarly for this side, negative. So if you put a voltmeter here across these two, you're going to get voltage, whatever here. If you cut this open, then you'd get nothing. Right? So there is a voltage difference here. And that just says that this is continuous. You know, if you turn this on, it's going to flow through here, flow back there. So that's the thing. Now, once you connect these two, then that's not going to happen because they're both connected. So electricity is going to be flowing. If you put a voltmeter in series like this with current that's flowing, it's just going to show 0 volts. Okay, it's showing voltage when they're disconnected. Once you connect them, it's just like imagine a voltmeter acts just like a light bulb. You could use a light bulb in its place. If you connect a light bulb to the same wire, like that, right, it's going to turn on. Oh, damn. Let me try to make... I'm not being good at explaining here. All right, the light bulb is going to turn on, but there's no longer going to be a true voltage difference here. But anyways, the main point... Yeah, I'm just drifting away here. The main point is that initially this is positive. Once these two are connected, there's no longer that difference there. It's just a continuous flow. Okay, so for here, remember this connected to the starter, which is connected to ground. So initially, if you were to put a light bulb from here to here, actually from here to the negative terminal of the battery, it would turn on. But if you put it once these two are connected, then the light bulb is no longer going to turn on because this is now negative. Remember, it's connected from here to there. Right, so now let's just assume, let's see what happens if that terminal is positive. Remember, initially it's positive. Well, it's going to go through here. Let's say you turn the relay on. Let's assume the relay is on now. These 2 points are connected. Electricity is going to flow through here, through here, through this coil, and then through here. Oops, it's open. So you don't have a flow of electricity. You know, electricity is stopped here. So if you've got nothing on, no starter, no plunger. Right, because remember, you got to have these coils on to pull that plunger in. So right here you have it's open. Let's see what happens to the other coil. Right away, this should suggest that this is wrong. This has to be negative. Right, so let's see what happens. But anyways, let's just see what happens, because the manual says that both of these have to be on to pull the plunger in. To pull the plunger in, both of them are on. Then once the plunger is in, one of them turns off. And you see I've drawn this thicker one here, and a thinner one. The thicker one is obviously the the stronger one, right? That's the one that just turns on and then turns off. This one remains on. This is the holding coil. That's the pull-in coil. So, anyways, let's just follow this again. Through here, through these points. We've done this one already. It's open. We go through here, the second coil. Remember, those two are connected to the same wire there. Remember on the previous video, right? The other one is connected to ground as well. So you don't have a flow of electricity. You have to have going from positive to negative or negative to positive. Doesn't matter in this case. Some cases it does matter, like an LED, right? It only flows in one direction, or some diodes or whatever. But anyways, if you don't have a continuous flow of electricity, you see, it's just basically going to itself. It's like connecting the positive terminal of the battery to itself, right? You don't get anything. You don't have, no light bulb turns on. So straight away, we should know that this is just connected to the starter. Sorry, this here has to be negative, right? Now, in order for that to happen, remember this is the negative terminal. Oh fuck, where the hell is it? This part here has to be connected to this negative terminal here. Now this entire part is negative. Remember, this part is what I'm representing with this wire here. The other side is just completely isolated. You see? That's how it is there. By this little thing here, this little washer makes the whole difference. Because now this terminal is connected to this plate. Whereas here, the terminal, you see, it's right in the middle. It's not in the middle now because there it is. Now it's in the middle. That's normal. You see? It's not touching the plate at all. And this thing, once again, prevents that from happening as well. So this is completely isolated from the plate. Plate is isolated from this. Now let's see if that makes sense. This here is connected to the negative of the battery. So it's always connected to the negative. Let's see if that makes sense now. So we start at negative. Okay, we should end at positive, right? If we end up negative again, then we have a real serious problem. Go through here. Let's assume, remember, this part here is just completely isolated from everything else. It's just a relay. The only thing it does is pull this in. That's it. You could reverse these terminals, do whatever. This only serves to close these points. That's all. So as I was saying, negative here, negative, negative. First coil, negative, negative, negative. We go through here. It's initially off, right? It's initially off, as it is now. Let's go through the second coil. Negative, 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 negative. It ends at positive. This coil is then energized. Oops, sorry, I fucked up here. Hang on. Did you notice what I did wrong? Let's go through that again. So this part is pretty simple. It's directly to ground. There it is. You see, that's that wire there. See, it's connected to the housing, which is ground. See there? It's soldered there. We've seen that in the previous video. Now the other coil that I said it's closed, remember? Through here. This is not connected here, but remember where this is connected to? This is connected to the starter. There's a starter there. Through the windings of the coils of the starter to ground. So both of them are on, you see. This one through the coil, through the coils of the starter, not to ground. Remember, the starter is connected to ground, which is, in this case, is a positive. And the other coil is just connected to the plain old directly here. Now, it's connected directly to the housing. This one isn't. It goes through all these coils. So what happens? Watch what happens. When these two connect, electricity then, instead of flowing from here to here, the negative of the battery starts flowing from here to here, and now you have basically electricity trying to go through here, and electricity trying to go through here to the same place. So basically, they're sort of fighting. Imagine that it's water, right? You've got water from one pipe, and then water from another pipe going in the opposite direction. They're sort of clashing together. So obviously, the strongest one is going to win. But in other terms, remember, this connects to this. This becomes negative. Now you no longer have a flow of electricity because remember, we have negative here. Negative here. Oops, it's reaching negative again, right? So there's two ways you can turn off an item in a circuit. You can either physically, mechanically disconnect it, or you can change that wire to the same wire, or change to the same polarity, if you will. So if that wire was positive, you change it to a negative, and it's the case here. Right, and I've just got another diagram. Now, right there's the starter motor, you see? That's one coil. The other coil remains on because it's connected directly to the battery. The other coil, it's going to turn off because you've got a lot more current coming directly from the battery. That's going there. The other terminal becomes negative. So a negative and a negative, there's no flow of electricity, right? I believe I did have another diagram, but yeah, that's the principle of electricity that's often overlooked. It's electricity goes through the circuit with least resistance. So if you've got a big, well, in this case you've got a big battery competing against the electricity that's coming through these coils here. Electricity coming directly from the battery is going to win. So by connecting these two, this terminal that's initially positive, remember, because it's connected here to the starter, to the ground. So it's initially positive. Once you connect these two, it's then connected to the negative from that's directly from the battery, and then it turns off because this terminal is no longer positive. It's negative. These are rough terms, guys. These aren't proper electrical terms. These are more for illustration. We'd need to go into a lot deeper understanding of electricity to really understand exactly how that works. But that's the basic principle there. So to summarize, to end this video, this series, this here, this steel, I think it's called grommet. Name Grommet is funny because it reminds me of Wallace and Gromit, right? Same guys that made Chicken Run. Sorry, not the same guys. Yeah, I mean, the same guys made Chicken Run, made Wallace and Gromit. But anyways, the negative terminal here coming directly from the battery, the one on the right here, is the one where that's connected to this plate here. The other one is insulated, so this plate is always negative, no matter what happens. I'm going to paint that in a bit and put some new rubber there, and that's it.